Good morning, everyone. My name is Ahad Nashal, and today I'll be presenting my process analysis video. Now, during quarantine and social distancing, I thought it's important to know how far of a distance one should keep from others. According to the WHO, it is essential to keep a distance of at least 3 feet apart from anybody around you. Therefore, I decided to build a device that will tell me exactly how far I am from the nearest person around me. Also, it could be a new hobby that you could pick up at home, assembling parts together. It's very easy and the parts are extremely cheap. Now, the main parts that we're going to be using are the Arduino board, the LCD display, and the ultrasonic sensor. The main part is the Arduino board. It is basically the brain of the entire device. It controls all the input and the output. It has the exact functions that each device should be doing. And as you can see, each pin has a label on it so that you could know exactly where to make the connections. We will also be using a USB Arduino cable to upload our program from our computer to the Arduino so that we can tell the Arduino exactly what to do with the devices it's connected to. To establish the connections between the Arduino and both of the other devices and the breadboard, we are going to be using the junction cables. On the right, we have the male-to-male cables, which have pins on both sides. On the left, we have the female-to-male cables, which have a pin only on one side. We will begin by connecting all the three devices together and supply power from the Arduino board to the breadboard to give the same power to the other devices. The pinholes on the board will help us establish these connections. Now, step 1, we will attach the sensor to the breadboard so that it is easier to adjust in any position we need and more stable. Now remember, the pins have to be stable in the pinholes to establish the right connection. Step 2, we will be connecting the pinholes on the Arduino board to the sensor using the breadboard. Now this specific connection will supply power from the Arduino board to the entire row in the breadboard. Now we'll make the connections between the Arduino board and the breadboard, but please make sure that these connections are connected to the right place. If any of the pins are not placed properly, the device will not function. Now that we have completed the connections of the sensor, the wires should look a little something like this. Now the wiring could look a little differently, but the pins should be almost the same. Step 3. We will begin by connecting the LCD screen to the Arduino board and the sensor. We will begin by attaching the female to male wires to the LCD screen. First, we will attach the pinless part to the LCD screen. Now that it's ready, we will start attaching it to the Arduino board and the breadboard for power supply. Now also, these connections will be shown on the screen. Now that the connections are made, it should look a little something like this. Also, to be sure that your connections are correct, you could follow this diagram to look at where the wire is going to and from. The next step would be to connect our Arduino board to our computer. This will enable us to download our software onto the Arduino board so that it knows what to do with the other two devices. This could be done by the USB cable. Our last step would be to upload our program onto the Arduino board. Now this code could be found in the description. First, we will need to verify it to make sure it's compiling well, and then we will upload it into the Arduino board. Once it's uploaded and all done, you could look at your screen and the screen should show you the exact distance from the Arduino board or the sensor to the nearest object. This was my process analysis video. Thank you.